So in this video, we're going to look at creating a box plot. So this is just another graphic you can create to analyze quantitative data, a set of quantitative data. So I've gone ahead and in my calculator, under Stat and then Edit is how I'm going to access my lists. So I went ahead and put into list 1 all of the number of states visited that we just used to create the stem plot in the other example. So I want to show you something real quick. If you go into your lists and it's already populated with some data, if you want to clear the data out of there, if you highlight the list name and then you hit clear and then enter, that will actually clear the data out of the list. If you accidentally hit delete instead of clear, it actually just hides the list. So don't worry if you hit delete and you think your list is permanently gone. It's not. And if that ever happens, you can just let me know and I'll show you how to get it back. So here's a list of states visited. And what we want to create here is a box plot. So in order to create a box plot, we need what's known as the 5-number summary. And the 5-number summary is the minimum value, the first quartile, the median, the third quartile, and the maximum value. And those are the numbers you need in order to create a box plot. So I'm going to show you how to get the calculator to do those for you. So I'm going to go to Stat, and then Calc, and then one variable statistics. And then you need to tell it what list contains your data. And the frequency list, unless you want to use some numbers in your list more than once, you're going to leave this blank. So I don't think I've ever used a frequency list at all. So, and then we're going to go ahead and calculate. And it's going to run through and it's going to calculate a bunch of statistics, summary statistics for this list of data. So that first number here is the average, the X with the little bar over it. This is actually the sum of the list. You don't really need these for much. This is if you square every number in the list and then add those up. These are the standard deviations, and we'll talk more later about the difference between those two and which one you use when. And then N is the number of values in your list. So there were 90 values in our list. And then we have our 5-number summary here. So there's our minimum value, our first quartile, the median, the third quartile, and the maximum. If you don't remember how to find the quartiles are really just the medians of each half of the set. So what you're doing when you're finding the quartiles, the median, and the median, you're taking a list of data, you're putting it in order, and then you're dividing it up into 4 equal pieces. So there are an equal number of values in each of the 4 pieces. So to get the first quartile, first you find the median, and then you take the lower half of the list and find the median of that. That's quartile 1. And then you take the median of the upper half of the list, and that's quartile 3. So you don't really need to know how to do that by hand. It's fine to have we're going to let the calculator do a lot of the grunt work for us. So if we're going to create the box plot by hand, we're going to have a number line laid out here to make sure that we encompass the minimum and the maximum. And then the box plot is sometimes called a box and whisker plot because there's a box in the middle and then there are whiskers that go out to either the maximum or some other cutoff, which we'll talk about in a minute. So for the whiskers, I'm just going to ballpark the minimum here, Q1 at 7. So the middle part's going to be the box, and the median at 10.5, the quartile 3 at 16. So there's my box and my whisker, and then the maximum out here at 40. So for right now, I'm going to draw that whisker all the way out to 40. But we're eventually going to want to look for potential outliers. And there's a rule of thumb that we can use for that. And you can also use your calculator or some other software. I'm going to show you how to do this on Statplet in a minute. But if you've got a graphing calculator at your disposal, once you have the data in your lists, if you do second y equals, this is going to take you to your list of plots. These are all the plots that you can use to create a histogram, a box plot. You can do a couple other plots as well. But for the quantitative data that we're looking at here, we've got the plot already turned on. And then if you look, so we've got a scatter plot, and then we've got these 2 box plots. So let me highlight something else you can see. So if you'll notice here, this one is a box plot with some little dots at the end, and this one is not. So what that means here is that this option right here is a box plot that will also include in the graph any potential outliers. So once you get that set, we're going to choose our list of data was in list 1. Frequency, that's just how often or how many times you want to count each value in the list. And then we're going to go ahead and I'm going to turn this equation off. And then I'm going to zoom 9, which is zoom stat. So that'll fit the graph to the window. So notice we've got these two little dots out here. So that means that we've got some outliers here. So we're going to show those on our graph the same way the calculator does. And if you hit trace and then arrow over, notice you can see at the bottom, there's your 5-number summary, right? There's your minimum, Q1. So you can see it down here in the corner, Q3. And then our whisker ends at 28. So I'm going to modify this so that my whisker ends at 28. And then I'm going to trace over and find out, well, that's a value of 38. And I arrowed over again. What that indicates, and the cursor didn't move, so that's an indication that there are 2 points right there. So there are 2 values of 38 there, actually. And then when I arrow over again, I get 40. So I'm going to indicate these on here as well. We've got 38 and 40. You can kind of put a couple there together if you want, so you can kind of see that. But it's also okay to just have 1 dot there. And you'll see in the technology, you'll only see 1 dot there. It won't indicate that there are 2 values there. And then the next question then becomes, where did that 28 come from? So I'm going to go back to my list and show you. So I'm going to go back to stat and then edit. So these are out of order right now, which is really unhelpful. So I'm going to sort the list. So under the stat menu, I'm going to sort this in ascending order. I'm going to sort list 1. And now when I go back to my list, all of these are in order. So I'm going to scroll back to the bottom of the list. And if you look, there's that 1 outlier, there's 1, there's 1, and this is where the 28 comes from. So we're going to draw that whisker out to the value, the maximum value excluding outliers. Okay? So in terms of describing a distribution using a box plot, we want to talk about the same kind of things we do when we're describing either a dot plot or a stem plot, or a histogram when we get to those. So you want to talk about the shape. So you're looking here. We can't talk about unimodal or bimodal with a box plot because I don't know. Right? I could get something, if I had a distribution that looked like this, I could have a distribution that looked like this. And in a box plot, what that's going to look like is this. That'll look like this. So I can't tell in looking at that box plot that the distribution is actually bimodal. So when you're describing the shape for a box plot, you're not going to address modality. So you're only going to address whether it's symmetric or skewed. So this one, let me go back to the graph here because it's a little bit clearer to see. So this is a little bit better than my hand-drawn one. So you can see here that this distribution is skewed a little bit to the right. It's skewed a lot to the right if we include the outliers. But we're going to kind of look at the distribution without those and describe the shape there. So for our shape, we're just going to say that the distribution of the number of states visited is slightly skewed to the right. For the spread, we're going to say, excluding the outliers, all of the students visited between, 3 and 28 states. And then we're going to also talk about how spread out the middle 50% are. So we're going to talk about how far apart Q1 and Q3 are. So we're going to say that the middle 50% of all students visited between 7 and 16 states. So again, what we're doing is we're allowing someone to, if they're not looking at the box plot, to get a good picture of what it does look like. And that distance right there, by the way, from 16 to 7, so that distance of 9 is what's known as the interquartile range, or the IQR. So for this one, the IQR is 9. And I got that from doing Q3 minus Q1. And so this is what we're going to use when we have a box plot. This is going to be our numerical measure of spread. And we don't want to use the actual range because the actual range can be greatly impacted by outliers, whereas the IQR will not be. So I can take this 40 and move it all the way up to here, and it's still not going to change. That IQR will still be 9. So the IQR is resistant to outliers. So we're going to use that as one of our measure of spread when we have a box plot. One other thing worth noting before we talk about how we determined that these are potential outliers, it looks as though there are more data values in here than there are in here. But know that each piece of this box plot really represents 25% of the entire data set. So there are the same number of values between 3 and 7. So in other words, there are the same number of students who visited between 3 and 7 states as there are a number of students who visited between 16 and actually 40 states. So know that because this is stretched out further, what that means is that that portion of the data is just spread out more. It doesn't mean there are more values in there, that there are more students between those values. So let's take a look at how we figure out what things are potential outliers. So there's this, I'm going to call it a rule in quotes because it's not a definitive be-all, end-all of where outliers are. It's really just a place to look for potential outliers. So what you do to find the potential outliers is we're going to find what we refer to as the fences. The fences are the boundaries of where we think our potential outliers may be. So if we exceed the upper fence, if any values exceed the upper fence, we're going to consider those potential outliers. And if any values fall below the lower fence, those are also going to be potential outliers. So the rule of thumb here to find the fences is we take this IQR, we multiply it by 1.5. And the 1.5 is really sort of arbitrary. I mean, the person who came up with this rule basically said 1's not enough and 2 is too many. So we're going to use 1.5. And that really is it. There's really no mathematical reason or proof of why you'd use 1.5. It is just a general rule of thumb. And this is going to determine the distance from the ends of our box that are going to be our fences. So in this case, I'm going to do 9 times 1.5, and I'm going to get 13.5. So I'm going to take this now, and I'm going to do my upper fence, or my lower fence is going to be my first quartile is going to be Q1 minus 13.5. So this will be 7 minus 13.5 is negative 6.5. So my lower fence is actually down into the negatives. So we're clearly not going to have any potentially low outliers because you can't visit a negative number of states. And then the upper fence is going to be the same idea, except now we're going to take Q3 and we're going to add 13.5. And that's going to be 16 plus 13.5 is our 29.5. So any students who visited more than 30 states, I guess, are going to be potential outliers. So the two students who visited 30 states or 38 states and the one student who visited 40 states, those fall well beyond this fence. So we should consider those to be outliers. If you had someone here at, someone who visited 31 states, yes, 31 is bigger than 29.5. But it's not that far removed from the next closest one, which is 28. So just because a number falls beyond the fence doesn't mean it's definitely an outlier. But that's where you should start looking, but then look at them relative to the other values in your data set. So if you didn't have the actual data, by the way, to figure out where to draw this whisker to, we could do this because we had the set of data and we could just pull those outliers out and look, okay, the next highest value then is 28. But you're not always going to have that. Sometimes you're just given the 5-number summary, and you can find whether or not there are potential outliers by finding the upper or lower fence and then looking at the minimum and maximum. If the minimum is well below the lower fence or the maximum is well above the upper fence, then we know there's at least 1 or 2 potential outliers. And that's all we can really say. We can't say how many there are. We know there's at least 1 if the maximum is significantly greater than the upper fence. And we know there's at least 1 if the minimum is well below the lower fence. And what you would do for the whisker then, if that's all you had, if you determined that, say, the maximum was an outlier, your whisker would be drawn up to the upper fence, or your lower whisker, or your down to the lower fence, depending on where your potential outliers are. So to recap what the what your answer would be if you were asked to describe a distribution from a box plot. So for this one, I would say that the distribution of the number of states visited is slightly skewed to the right. All students, with the exclusion of the students who visited 38 and 40 states, which was an unusually high number of states for students to have visited. All other students visited between 3 and 28 states. And the middle 50% of all students visited between 7 and 16 states. So that leaves us with an IQR of 9. So I also need to address center in that description. So I would also include that the median is 10.5 states. If you have a box plot, you should be using the median as your measure of center, not the mean. And we're using the median because it's right here on the picture. So if all you have is the picture, you'll just have to ballpark it. If you actually have the 5-number summary, then go ahead and cite it exactly. So we're covering distribution is skewed right. We're covering the spread by using the IQR. We talked about the outliers, and we mentioned the measure of center using the median. So I just want to show you how to do this on Statplet in case you don't have access to a graphing calculator, or if you have data that's easily you can easily cut and paste. This is probably the better option anyway. So I've already got this in here from when we did the stem plot. So pretty straightforward here. We're just going to go ahead and select box plot, and then there it is. So they give you the summary statistics. They include the mean and the standard deviation here. I'm really not sure why. I kind of wish they didn't, because when you talk about a box plot, you should be using the median for your measure of center, and we're going to be using the IQR as our measure of spread. So really, you shouldn't be using these for anything when it comes to describing a box plot.